Hello Math 30-2 and welcome back to your 8th lesson, which is rational equations. So basically we learned how to add and subtract rational expressions. We learned how to multiply, divide. Now we're going to learn how to solve for them, okay? So just to start off, we're looking at something we looked at in grade 11. Here's an equation, algebraic equation, or a quadratic equation to be more specific, and it wants us to solve for it. So let's try and solve for this. Now let's take a look here. First thing, as soon as it's quadratic, is we must make it equal to 0. So I have x squared minus 9x plus 20 is equal to 0. I just added 20 to both sides. Okay? Next thing we're going to do is I'm going to use my trusty box method to solve for this. So I have 20 and negative 9. Okay? So this one here always goes there. The negative 9 goes on the bottom. Now I have to figure out what multiplies to give me 20. Well, I have 5 and 4, that's one of them. And gets negative 9. Well, if they're both negative, that's going to work. So when it's factored, I get x minus 5, and I have x minus 4. Now looking at this, if this value here is equal to 0, it's going to be 0 multiplied by whatever that is. This will not matter. That x minus 4 doesn't matter if that's equal to 0. Same thing here. If this value here is equal to 0, doesn't matter what that is, we're going to end up getting 0. So I'm going to have now x minus 5 equal to 0, or x minus 4 equals to 0. So we have two answers, which gives me x could equal to 5, or x could equal to 4. Instead of or, we could say and as well. Okay? Let's take a look at the next one. Next one's a little bit more tricky because we have that there. First thing we're going to try and figure out, though, is can we divide everything by 6 or x? No. So we can't simplify that anymore. So now we're going to use the trusty box method again. Okay? But we have to add a step because there's a leading coefficient of 6, so it's 6 times 5, which gives me negative 30. And then the bottom here is 13. Now I look at it, what two numbers, when we add them, or when we multiply them, gives them negative 30, and we add them, it's 13. So we know one must be positive, one must be negative, because that's a negative. Okay, they have to be different symbols. I look at this, I have 15 and 2. Well, that works. So I'm going to put the bigger one must be positive, because that's positive, so 15 and 2. So I have negative 2 all over. Now we must put this 6 there by an x, 6x, and I have 15 all over 6x. And let's simplify these two fractions. This is going to end up giving me negative 1 all over 3x. And this one here is going to give me 5 all over 2x. Now I could put these into factored form. So I'm going to have 3x subtract 1. And we have 2x plus 5. And this is equal to 0. Okay? The other way of doing this is you could just graph in your calculator and find your x-intercepts, okay? And that will be your solution. You could do it that way as well, put it in fraction form at the end, okay? So your x-intercepts, you could use that way as well. But now let's try and solve this out here. So I know this could equal 0, this could equal 0. So we have 3x subtract 1 can equal to 0, or we have 2x plus 5 can equal to 0. So I solve for this, we add 1, divide by 3, and we're going to get x is equal to 1 over 3. And x could also equal to, we subtract 5, so it's negative 5 divided by 2. Okay? So those are my two solutions. So here we go. Now that we're done a review, most of that was in grade 11, we're going to look at solving actual rationals. So that's when the x is on the bottom. So my first thing we must always do is state our non-permissible values. Because anytime we have a rational, first thing we always do is state non-permissible values. So let's take a look at number 1 here. My n, non-permissible value, is negative 3. X cannot equal to negative 3. Now let's look at number 2. It wants us to solve. It says verify the solution by solve the equation algebraically. So a lot of you guys could do this here, but I'm going to solve it algebraically. Now my hint is we're going to multiply everything by everything on the bottom. This is really over 1. So I'm going to multiply this by x plus 3 and by 1. And this here is going to be by x plus 3 and by 1. Okay? So the tops are multiplied, not the bottoms for this. It's kind of tricky, but you'll see why. So here I'm left with x plus 3 multiplied by 3 all over x plus 3 is equal to, and multiplied by 1, I don't have to really write that out, 6 multiplied by x plus 3 all over 1 multiplied by 1. Now we're just going to, and there's a 1 now, we're going to cancel off now everything we can once we do this. So my next step is we're left with 3 is equal to 6x plus 3. Okay? Some of you could cross multiply for this, but since we have adding and subtracting there as well, cross multiplying gets a bit complicated. So now I'm going to multiply my 6, so I'm left with 6x plus 18 is equal to 3. And now solve for x. So I get, let's see here, 15, negative 15 is equal to 6x, divided by 6, divided by 6. So I'm going to, this simplifies down, both of those could be divided by 3. So I'm going to be left with negative 5 is equal to x. Oops, negative 5 over 2 is equal to x. All right? Now it wants us to verify the solutions using algebraically. So I'm going to just put in negative 5 over 2 for x. So we have 3 all over, let's have negative 5 over 2 plus 3, is that equal to 6? So I plug this into my calculator, or I'm just going to add it myself. So that's 3 all over negative 5 over 2 plus, what is this, 6 over 2, which is the same thing as 3 all over 1 over 2, which gives me the same thing as 6, which is equal to this 6, so that's correct. Now, if you plug it into your calculator, all you do is you just find the intersect, and that is the answer as well. This is how to do it algebraically. Now let's take a look at B. B is a little bit more complicated. If we look at this, I have this here and that here. You could either cross multiply, but I'm going to do it my way. Okay, just multiplying everything out. So when we get to later equations, it could get a little bit more challenging. So let's first take a look here. What are my non-permissible values? So let's take a look at number 1. Non-permissible values, x cannot equal to negative 3 and negative 7 over 4. Okay, so those are my non-permissible values. Now, let's get rid of these denominators. I don't like them. We don't like denominators, so we're going to get rid of them because it's easier if it's in rational form. Okay? So, first of all, I'm going to multiply everything here by x plus 3, and this one here by 4x plus 7, and this one here is going to be by x plus 3. Okay? So, we end up with 3, 4x plus 7, all multiplied also by x plus 3, all over x plus 3 is equal to, we have 9 multiplied by 4x plus 7, all multiplied by x plus 3. We multiply everything by all the denominators. Remember, that's what I say, that's my key. And then we're going to divide this by 4x plus 7. Now we look at this and this cancel off, this and this cancel off. So now we can multiply everything in. So 3 times 4, which gives me 12x plus 21 is equal to, we have 9x plus 27. Okay? Now, now we're going to try and solve for x. So I'm going to put my x's all on that side, on this side here. So I have 12x, subtract 9x is equal to 27, subtract 21. This is going to give me 3x is equal to 6, x is equal to 2. And then let's check this out, see if it is true. So 3 over 5, is that the same thing as 4 times 2 is 8, 15, 9 over 15? Yes, it is. As we multiply that by 3, that's the same fraction. 3 over 5 is the same as 9 over 15. That is true. All I have to do is multiply everything here by 3 over 3, and that is the same. All I did was I put in 2 for x. Something out of it. Okay? And if you put in your graphing calculator, just find the x-intercept of this equation here. Which equation? You just put it, you just graph this part here. I would graph, where is it? We just solve it and we graph the x-intercept when we put all this and make it equal to 0. And you verify it with your calculator. Okay? Alright. Here we go. Consider this next following rational equation. All right? Rewrite the equation with one term on each side. So we want to rewrite the equation with one term on each side. So I'm going to finish this off. We're going to have 2x all over x plus 2 is equal to 5 all over x plus 3. Now it says determine the roots of the equation by cross multiplying. So this one here wants us to cross multiply. So it's the same as what we did before, except here we're going to cross multiply. Kind of same idea. So we have 2x multiplied by x plus 3 is equal to 5 all multiplied by x plus 2. Okay? And we cross multiply, so everything's done. And then we're just going to solve. So, or we're going to try and do our best to solve. So here we're going to get 2x squared plus 3x, plus 2x is equal to 5x plus 10. So now I have to move everything to the one side. So we're left with 2x squared plus, plus 2x minus 5x. So we get minus 3x, and we have minus 10. It's equal to 0. So now we must factor this. So I'm going to have here, box method, negative 20, and we have negative 3 on the bottom. So a difference of 3, that gives us 20. We know 4 and 5. And we also have negative 20. Just wait, did I make a mistake here? 5 plus 3, 2. Whoops, sorry. 2x times 3 is 6x. This should be 6x. There we go. 6x minus 5x gives me plus 1x. There we go. There was my mistake. So this is plus 1. So we have 5 and 4. This is going to be negative. So I have now, we look at this, we have 5 over 2x, because there's the 2 there, and we have 4 over 2x. This can be simplified to 2 over x. So we have x plus, oops, sorry, was it minus? X minus 2, because this was negative. X minus 2. And this one here is going to be 5x, because this can be simplified, or 2x plus 5. Okay, then we have x equals to 2 and negative 5 over 2. And that's it. Okay? Alright, so here is number 4. It says Leo was solving the rational equation. His work is shown below. So line 1. Okay, so here's his work. Leo's answer is not correct. Explain the work in his error. Alright? Well, I look at this here, line 1, that looks fine. He cross multiplied, that's fine. Line 2, yeah, everything's multiplied in, that's good. Line 3, still looks good. He subtracted 4x and added 4 to both sides, still good. Line 4, he factored it. Let's see, do the quick box method. 4, negative 5, yep, negative 4 and 1. Solution is 1 and 4. Now, where is his answer wrong? I would say it's this, because his non-permissible value is here. Because the non-permissible value is right there. X cannot equal to 1. Therefore, when he solved and he got x equals 1 as one of his answers, that cannot happen because of the non-permissible values. And that's it. Okay, let's take a look here at question number 5. Now this one is a little bit more difficult as we have this here. So state the non-permissible values and solve the equation algebraically. So for this one, my non-permissible values is, well, x cannot equal to 0. Okay? Put this one right there. Now, what I'm going to do is, first of all, is I'm going to rearrange everything so I have everything with the same denominator on one side, everything without on the other. Alright? So I'm going to end up having here, I'm going to move this to this side, and this to this side. So I'm going to get negative 1, because we have to subtract 3x, over x is equal to 2. Okay? Now I'm solving this. I'm going to get negative 1 is equal to 2x. So then I'm going to end up getting x is equal to, divided by 2, x is equal to negative 1 over 2. And that is it. Okay? Let's take a look at the second one. Now this one here, we have 3 things, but we have only 2 with different denominators. So I'm going to move this to that side. So I have everything with one denominator on one side and with the other denominator on the other side. So I end up getting 2 over x minus 1 is equal to 4 subtract x. Now I'm going to cross multiply. So 2 is equal to 4 subtract x multiplied by x minus 1. Okay? Which is going to give me, we have negative x squared, and what else do we have here? Negative x squared, and I'm going to have 4x, 5x, and negative 4. Okay? That's 2. Alright? Now, let's try and put this all together here. And I'm going to put everything on this side. So then this becomes positive. So I'm going to have x squared. And I will have minus 5x, negative 4, and plus 6 is equal to 0. So then, when I factor this, I'm going to have 6, negative 5. That is going to be 5 and 1, both negative. Okay? So I get x minus 5, x minus 1. So x is equal to 5 and 1. Okay? But look at my non-permissible values. X cannot equal to 1. So my answer is just 5. Alright? Let's take a look at C. Now C is a little bit more different, isn't it? I take a look at this here, and I have 3 different variables. So my non-permissible values is equal to 1 and negative 1. Alright? X cannot equal to 1 or negative 1. But we have this here. So what I'm going to do is I'm going to multiply everything by my denominators. So the side here, I'm going to have x plus 1 multiplied by x minus 1 multiplied by 3 plus. It's all over x plus 1 plus. Here I'm going to have x plus 1 multiplied by x minus 1 multiplied by 1 all over x minus 1. And here I'm going to have x plus 1, x minus 1, all multiplied by 2. And that's all over 1. I didn't include the 1 because we have to multiply that 1 in. It doesn't really matter. Now let's see what cancels off. This and this cancel, this and this cancel, and that's it. So I'm going to be left with 3x minus 3 plus, so now we have no more denominators. We have x plus 1 is equal to, now I have to multiply all this together. This is going to give me x squared. Oh, it's a difference of squares. So x squared minus 1 times 2 is the same as 2x squared minus 2. Because that's the difference of squares, which would be 2, which would be x squared minus 1, and then I have to multiply it by 2. Okay? So now let's solve, make it equal to 0. I'm going to put this side 0 because this has my x squared. So I have 2x squared, and I combine this, that's 3, 4x, so I subtract 4x, and then I have that 1 and 3, combine those, that's negative 2, so that's like plusing 2 to negative 2, and that's it. So I plus 2 minus 2, so that's just going to give me this. Now, I take a look at this here. I could divide everything, so we have 2x, and I'm going to be left with x subtract 2. So x is equal to 0 or 2. Okay? And those are my 2 values. Alright. Let's take a look at number 6. This one here says correct the following work. And they use cross multiplication here. I think can't we use, or least common denominator method. So that's the one I tend to use, is least common denominator. I just have all the common denominators and multiply them together and we cancel off. Alright? So now this one says here, what do you notice about the student's work? One's cross-multiplying, one's least common denominator. So, in the end, they both reach the same step. Complete the work to determine the solution. Well, I'm going to leave that up to you because this is just a term of multiplying out, simplifying, and so on. The main steps are there. And I'm just going to do now question number 7. All right, here we go. So it says, determine the roots of this equation. So we want to solve for x in this last question, question number 7. So first thing, if I look at this, there's a lot of different roots, so I'm going to use lowest common denominator to solve. Now, first of all, I want to know what are my non-permissible values. So what can x not equal to? I look at this here. I'm going to factor this out, everything first of it. So I have 16, I have x minus x, and then we have x minus 4. Okay, is equal to 4 all over x subtract 4. And then this is going to be the same as minus 1 over x. So x cannot equal to 4 and 0. Now, looking at this, what do I have to multiply everything? By the lowest common denominator. So let's multiply everything by lowest common denominator, all the tops. So this first one, my lowest common denominator is equal to x and x plus 4. So let's take a look at this one. We have x multiplied by x plus 4 multiplied by 16 is all over x plus 4. Okay, it's equal to 4 multiplied by x plus 4 over x. Oh, sorry, it's minus 4. I don't know why I said plus 4. It's minus. Subtract. All over x subtract 4. And the last one is going to be minus 1 x multiplied by x subtract 4 all over, better fix this here before I make a mistake, all over x. Okay, so let's cancel off what we can. This and this is gone, this and this is gone, this is gone with all of that. Okay, so I'm left with 16 is equal to 4x minus this is subtract all of this minus x plus, or x subtract 4. Okay, so when I do that, this is going to give me 16 is equal to 3x plus 4, because it's minus both of those. So I end up getting, I move that 4 there, 12 is equal to 3x, and then I end up getting x is equal to 4. But we have here, x cannot equal to 4. Therefore, we have a problem. If x cannot equal to 4, there is no solution. Because we said x cannot equal to 4. So there is no solution. I hope you understood everything. Good luck as we work on all of this later.